Hello there, you're welcome once again. Today we are looking at solving quadratic equations by factoring the second part. If you have not seen the first part, the link is in the description below. We had in the first part looked at how to solve quadratic equations by factoring using conventional factoring techniques and the slide and divide method. But today we shall be considering difference of two squares and quadratic equations that factor out as perfect squares. We had also in our previous tutorials shown the factoring technique of perfect squares and difference of two squares. If you have not seen them, the links are in the description also. You can check them out. The first example we shall be considering is x squared minus 9 equals to 0. A look at this shows us that we are having difference of two squares. This means that we have x squared, which is a squared. 9 can actually be expressed as 3 squared, and that equals to 0. And then factoring difference of two squares, if we have difference of two squares like a squared minus b squared, this factors out as a minus b, a plus b. What does this mean for the equation we have? It means that the left hand side of the equation becomes x minus 3 x plus 3 equals to 0. And by the zero product property, you can see that, check that out in our last video. By the zero product property, that is when two numbers multiply and the product gives 0, it's either the first one is 0, so x minus 3 is 0, or the second one is 0, x plus 3 equals to 0. And what will make x minus 3 to be 0 is when x is 3. And what will make x plus 3 to be 0 is when x is minus 3. So we can say the solutions to this quadratic equation, or the roots, are x equals to plus or minus 3. That is the behavior of difference of two squares. Let's take another example on difference of two squares. So the first thing we're going to need to do here is to rearrange by writing it as 4x squared minus 25 equals to 0. Then 4x squared can be written as 2x all squared, as 4 is a square, 2 squared. Then minus 5 squared equals to 0. By applying the concept of difference of two squares, this is going to be 2x minus 5, 2x plus 5 equals to 0. And by the zero product property, 2x minus 5 is 0 when their product is 0, or 2x plus 5 is 0. So when 2x minus 5 is 0, it simply means that 2x will be 5. And when 2x plus 5 is 0, 2x is going to be negative 5. Then dividing both sides by 2 in each case, x is either 5 over 2 or x is either negative 5 over 2, minus 5 over 2. As is the case with difference of two squares, the roots or the solutions will be plus or minus 5 over 2. On to another example. This one is not difference of two squares. However, let us analyze it. In analyzing this, we'll see that x squared is the square of x. Then considering the last term, plus 9. 9 is the square of 3. Then the middle term, 6x. 6x is twice the product of x and 3. Anytime we have a situation like this, the expression factors out as a perfect square, with the sign before the second term, before the middle term, giving us the sign in the bracket. So this x squared minus 6x plus 9 equals to 0, thus becomes x minus 3 all squared. Now, if x minus 3 all squared is 0, it simply means that x minus 3 times x minus 3 equals to 0, which is the meaning of squared. Then x minus 3 is 0. The second one also, x minus 3 is 0, which means that x is going to be 3. When 3 is added to both sides, x is going to be 3 twice. Such is the behavior of perfect squares. Equal roots. Perfect squares have equal roots. Here is another example, 16x squared plus 40x plus 25 equals to 0. Let's analyze it first. 16x squared is 4x all squared, that is the square of 4x. The last term, 25, is 5 squared, the square of 5. Then the middle term, 40x, is twice the product of 4x and 5. So this means that 16, the equation 16x squared plus 40x plus 25 equals to 0. The left hand side factored out as 4x. Then it's going to be a plus in the middle because we have plus before 40. 4x plus 5 all squared equals to 0. Now, as before, this is a perfect square, which means we are going to have a repeated root such that 4x plus 5 must be equal to 0 twice. Then 4x must be equal to minus 5 twice. And dividing both sides by 4, x is going to be minus 5 over 4 twice as the solution or the root of the equation. We believe that you have learned the concepts of perfect squares and difference of two squares when solving quadratic equations. Here is an exercise for you. Attempt it and show us the solution, or you send the solution to the comment section below, or you can forward the solution to the email address attached to this video. But before we close this video, let us take a graphical outlook on perfect squares and difference of two squares. Here is the graph of y equals to x squared minus 9, the very first example we looked at under difference of two squares. And here you will see that the curve, the quadratic curve, cuts the axis, the x-axis, at both the negative 3 and the positive 3. That is how difference of two squares behave. And you also realize that the curve is symmetrical about x equals to 0. So the vertex for difference of two squares is always x equals to 0. Now here is a look at how perfect squares behave. Perfect squares, since they have a repeated solution, repeated roots, then the curve will only touch the x-axis at one point. In this case, it is touching at the point x equals to 3, and that's also the vertex. So when it comes to perfect squares, the solutions correspond to the vertex. If you are yet to subscribe, please do so now. Hit the notification bell so that you can get updates on when our next videos come out, especially as we continue on our journey to solutions of quadratic equations. Thank you for watching the video. Bye.